Hello, welcome to the Bakwas channel for self-paced tutorials on Internet of Things. This presentation is an introduction to the Arduino GIGA R1 Wi-Fi board. The STM32H747XI microcontroller has two cores that can run separate programs or sketches. The more powerful core is the ARM Cortex-M7. The other core is the ARM Cortex-M4, which requires support from the M7 core for its boot process. Both cores are 32-bit with floating-point units and operate under the mbed operating system autonomously. The onboard Wi-Fi Bluetooth module is the Murata LBEE5K L1DX-883. There is an external antenna connector on the board since it does not have a built-in antenna. The chip and the antenna connector are highlighted in the image. There are three different types of memory on the board. The microcontroller has 1 megabyte. The 8 megabytes SD RAM is accessible separately. There is also 16 megabytes flash memory for storage purposes. The board has more pins than any other Arduino board. There are too many important details that cannot be covered in a simple slide. Please refer to the support documentation for the details. The board supports 4 separate serial ports. One can print and monitor different variables to different interfaces simultaneously. The board has 3 separate I2C buses, of which 2 are usable without external components. There are 2 serial peripheral interface buses, one as a header and the other through pin connections on the board. There is one controller area network bus, but it does require an external transceiver that is not included in the package as an accessory. The board has 2 USB connectors, USB-C for powering, programming, and human interface device communication, USB-A for USB host connecting keyboards, USB sticks, etc. There is an onboard Arducam compatible connector that allows certain camera modules to mount directly on the board. There is an internal 2D graphics accelerator with support for resolutions up to 1024 by 768 that is respectable to drive a touch screen. The board features an audio jack with 2 times digital analog channels and 1 analog digital channel, and is capable of reading input from a microphone as well as transmitting signals to a speaker. The board features a 2x5 pin joint test action group connector, giving advanced debug functionalities for more advanced users. The board expects power from the USB-C port or the WIN pin. The USB-C port requires 5 volts, while the WIN supports the range from 6 to 24 volts. The internal operating voltage is 3.3 volts, which should not be exceeded for general-purpose input-output pins. The GIGA R1 WiFi is a powerful feature-packed board with a large amount of general-purpose input-output pins and dedicated connectors. The key features include, but not limited to, dual-core microcontroller, mbed operating system, 76 GPIO pins, advanced analog to digital, digital to analog controllers, camera and display connectors, rich USB interface, USB-C and USB-A, Bluetooth, Micropython support. Later on in this tutorial, we will briefly illustrate some of these features with the most simple exercise. There are three integrated development environments for the GIGA board. The web editor has cores and libraries already installed, ideal for beginners and who need to keep the sketches saved securely in the cloud and synced across devices. Arduino IDE 1.8 is the classic offline editor that has been popular through decades of happy users. Arduino IDE 2.0, with features like debugging and code highlighting, make coding faster and easier. This is a great choice for both beginners and more advanced makers. The link to download Arduino IDE 2.0 is listed on the slide. This IDE definitely improves programmer productivity with key features such as revamped user interface, improved board and library manager, debugger, autocomplete, and many other features. It is available for all major platforms. Let us get started with the simplest Arduino sketch. In the Arduino world, programs are called sketches. Launch Arduino IDE 2.0, install the board package for GIGA, connect the GIGA hardware to the desktop using the corresponding USB cable. Since there will be only one GIGA board at this time, it should be relatively easy to identify it. Make a note of the corresponding port assignment. The nomenclature may vary slightly, and since the connections are dynamic, it may change from one development session to another. Verify and upload a compatible example. The board supports Micropython with its built-in interpreter that does not require the conventional compilation step. There are two development environments for Micropython: Arduino Lab for Micropython and Thorny. One of these environments is strongly recommended for Micropython development work on Giga. Also, a command line utility and firmware are essential prerequisites to running Micropython on Giga. The Giga board has two cores, M7 and M4. M7 is the main processor and has superior hardware features. M4 is booted from M7. The two cores can run separate sketches in parallel. In the Arduino IDE, select the Board Manager button. Enter Giga in the search field and press Enter. The Giga library should be displayed. Select the Install button, connect the desktop to the Giga board, and confirm that the board now appears to be connected through a specific port. Open an example sketch by drilling from the menu bar through File and then Examples. As in any Hello World exercise, there is the Hello Blink equivalent for Arduino boards. Compile and upload this sketch. Wait for the download to the board to complete. The onboard LED will blink indefinitely until the code is stopped. Let us review the steps one more time. The Arduino IDE 2.0 was installed previously. Its installation will not be demonstrated in this section. The key sections of this demonstration are: apply updates to the board library, if any, ensure that the board has been identified by the IDE, open a sketch, compile and upload to run the sketch. If one is using the Arduino IDE 2.0 for the first time, then it is important to ensure that regular users can have access to the USB port to upload the code. Here is a very simple bash shell script to perform that operation once. As you can see, there is a command there for the USB and the vendor ID and the mode 666, which is read and write access to the port. Run this shell script from the command line, and you will require elevated privileges to run this. As you can see on the slide, that the standard execution of the command fails with the prompt to run as root. If we go ahead and log in with elevated privileges, then we need to ensure that we're using the right account. Once we log on with the right account, the command executes without any issues, and the user will have access to the USB port. Launch the Arduino IDE from your desktop. In this example, we're using Ubuntu as the desktop platform. After connecting the board to the desktop using the USB-C port, click the Boards Manager toolbar button and enter GIGA to search for the libraries for the board. Click on the Install button, and in due course, the library for the board will be installed. Load the default Blink sketch and click on the Compile button on the toolbar. It just takes a few seconds to compile this simple sketch, and the confirmation message is displayed in the output pane. Once that is complete, as a formality, you can proceed to upload the code to the board by clicking on the Upload button on the toolbar. This tutorial was a basic introduction to the Arduino GIGA R1 Wi-Fi board. The key features of this board were enumerated. The library for the board was transferred to the board. The classic Blink example was run to validate that the library for the board works. Naturally, in due course, there will be more examples with this board. That's all, folks. Please provide feedback in any which way you can. This presentation was prepared with assistance as noted on the slide. My apologies if I have unintentionally omitted anyone or any resource. A very big thank you to y'all. Come back soon to the channel.